Okay, so I had to cut my last video off short. I was starting use list in Kotlin, Kotlin basics in Android, and I did a part one video to this, and it is unit two, the last pathway, pathway three, and it's the first lesson in there. And I went over the introduction to lists, but I ran out of time earlier today, and now I'm going to be doing the introduction to mutable lists. So this is part two of this use list in Kotlin tutorial. Mutable lists are lists that can be modified after creation. You can add, remove, or change items. You can do everything you can do with read-only lists as well. Mutable lists are of a type mutable list, and you can create them by calling mutable list of. All right. Create a mutable list. Delete the existing code in main. Within the main function, create an empty mutable list and assign it to a val variable called entrees. Entrees of equals mutable list of. This results in the following error: not enough information to infer the type. As mentioned earlier, when you create a mutable list or list, Kotlin tries to infer what type of elements the list contained from the arguments passed. For example, if you write list of noodles, Kotlin infers that you want to create a list of string. When you initialize an empty list without elements, Kotlin cannot infer the type of elements, so you have to explicitly state the type. You do this by adding an angled bracket right after the mutable list. Alright, so let's do that. Val entrees equals mutable list of type string. Okay. Alright, no errors. Another way you could have fixed this error is by specifying the data type of the variable up front. Val entrees of type mutable list string, mutable list of. So either way would work. Note, you can use val for a mutable list because entrees variable contains a reference to the list, and that reference doesn't change even if the contents of the list do. Print the list. Print entrees. Okay, but there's nothing in it yet. Oh, forgot to put it in parentheses. Or in quotation marks, sorry. Yeah, so that works good. Add elements to a list. Mutable lists become interesting when you add, remove, and update elements. Add noodles to the list with entrees.add noodles. And the add function returns true if adding the element to the list succeeded and false otherwise. Print the print the list to confirm that noodles has actually been added. Add noodles. Okay. Entree.add noodles. Okay. And then print entrees. Why am I adding noodles in a print line though? Hmm. Hmm. Okay, so it works that way too. So you don't have to do it in a print line. Okay. All right. The output is add noodles true, entrees noodles. Add another item, spaghetti, to the list. Print line add spaghetti, uh, entrees dot add spaghetti. Okay. Print line entrees. How do you spell spaghetti? Spaghetti. Yeah, that's what I thought. That's spaghetti. Okay. Instead of adding elements one by one using add, you can add multiple elements at a time using add all and pass in a list. Create a list of more items. You won't have to change it, so make it a val and immutable. Val more items equals list of. Okay. Ravioli, lasagna, fettuccine. Oh, sorry. Okay. Val more items equals list of. What were they? Ravioli, lasagna, fettuccine. Lasagna. Spell fettuccine. Yeah. TTCC. TTCC, not NN. Fettuccine. Okay. All right. And then we're going to add more items to entrees. So, print line, add more items. It said to use add all, I think. Add all. Did it work? Okay. Add more items, true. Noodles, spaghetti, ravioli, lasagna, fettuccine. All right, good. All right. The output shows that adding the list was successful. The entrees list now has a total of 5 items. Now try adding a number to the list. Entrees.add 10. The integer literal does not conform to the expected type string. This is because entrees list expects elements of type string. Okay. And you are trying to add an int, remember to only add elements of the correct data type to a list. Otherwise, you will get a compile error. This is one way that Kotlin ensures your code is safer with type safety. Remove the incorrect line of code so that your code complies. Remove the incorrect line of code. Remove elements from a list. Call remove to remove spaghetti from the list. Print the list again. Okay, remove spaghetti. So okay. We're gonna call entree dot remove, and we are gonna remove spaghetti. And that's it. It removed spaghetti. Removing spaghetti returns true because the element was present in the list and could be successfully removed. The list now only has 4 items left. Remove spaghetti equals true. Entrees, noodles, ravioli, lasagna, fettuccine. What happens if you try to remove an item that doesn't exist in the list? Try to remove rice. Okay. So I will remove rice. Nope, sorry. False. And it just prints the same list. The remove method returns false because the element does not exist and therefore could not be removed. The list remains unchanged with only 4 items still. Okay. You can also specify the index of the element you want to remove. Use remove at to remove the item at index 0. Remove at. Okay. Okay. If you want to clear the whole list, you can call clear. No, that's empty again. The output now shows an empty list. Kotlin gives you a way to check if the list is empty using isEmpty function. Try printing out entrees.isEmpty. True. Output should be true because the list is currently empty with 0 elements. The isEmpty method is useful if you want to do an operation on a list or access a certain element, but you want to make sure that the list is not empty first. Here is all the code you write for mutable lists. Comments are optional. Add individual items. Add a list of items using add all. Remove items. Yeah, that's what I have. Just don't have the comments. Okay, loop through a list. To perform an operation on each item in a list, you can loop through the list, also known as iterating through the list. Loops can be used with lists and mutable lists. While loops. One type of loop is a while loop. A while loop starts with the while keyword in Kotlin. It contains a block of code with curly braces that gets executed over and over again as long as the expression in the parentheses is true. To prevent the code from executing forever, called an infinite loop, the code block must contain logic that changes the value of the expression so that eventually the expression will be false and you stop executing the loop. At that point, you exit the while loop and continue with executing the code that comes after the loop. While expression While the expression is true, execute this block of code. Note that a while loop doesn't need to involve a list, example here, but it is useful for lists. Use a while loop to iterate through a list. Create a variable to keep track of what index you're currently looking at in the list. This index variable will keep incrementing by 1 each time until you reach the last index of the list, after which you can exit the loop. Delete the existing code from Kotlin Playground and have an empty main function. All right. Empty main. Let's say that you are organizing a party. Create a list where each element represents the number of guests that RSVP'd from each family. First family said 2 people would come from their family. Second family said 4 of them would come, and so on. Val guests per family equals list of 2, 4, 1, 3. Guests per family, list of 2, 4, 1, 3. Okay. Figure out how many total guests there will be. Write a loop to find the answer. Create a var for the number of guests and initialize it to 0. Initialize the var for the index variable as described earlier. Var index equals 0. Write a while loop to iterate through the list. The condition is to keep executing the code block as long as the index value is less than the size of the list. Index, while index is less than guest per family dot size, do this. Okay. So while index is less than total number. Oh. Well, guess then while index is less than guest per family dot size, execute this code in here. So first we're gonna do total number of guests. We're going to do index incrementing plus plus. What do we do with total guests? Within that loop, get the element of the list at the current index and add it to the total number of guests. Okay. Remember that total guests plus or equals guests per family index is the same as total guests equals total guests plus guests per family. Okay. They said plus equals is the same? Yeah. Guests per family. Total guests equals guests per family index. Yeah. Total guests. Guests per family index. The total number of guests equals guests per family dot index. Okay. So 2, right? And index is 0. And then an index of 1, it has 6, so it added the 4. Okay. And then at index of 2, it has 7, so 10. So, okay. 6, and then it adds 1, it gets to 7. All right, there we go. And then it adds 3, it gets to 10 at index of 3. Okay, which is actually 4 because index 0. Okay, so it works. All right, so I can delete these. I was just checking if it worked. All right, and then notice that the last line of the loop increments index variable by 1, so that the next iteration of the loop will look at the next family in the list. After the while loop, you can print the result. Print total guest count. Okay. Mm. Oh, didn't put it in quotes. Total number of guests at the wedding will be 10. Yep. Here's the full code. All right. Because doing simple operation on a variable and storing it back in the variable is common, there is a shorthand for using the plus equals operator. There are equivalent operators for minus equals, multiplication equals, and division equals. See more details here for operators. Cool. With the while loop, you had to write code to create a variable to keep track of the index, to get the element at the index in the list, and update that index variable. There's an even faster and more concise way to iterate through the list. Use for loops. A for loop is another type of loop. It makes looping through a list much easier. It starts with the for keyword in Kotlin, with the code block in curly braces. The condition for executing the block of code is stated in parentheses. For number in number list. For each element in the list, execute this block of code. All right, this is an example. In this example, the variable number is set equal to the first element of the number list, and the code block is executed. Then, the number variable is automatically updated to the next element of the number list, and the code block is executed again. This repeats for each element of the list until the end of the number list is reached. Delete the existing code in the Kotlin playground and replace it with the following code. Function main, val names list of Jessica, Henry, Alicia, and Jose. File names list of Jessica, Henry, Alicia, Jose. Add a for loop to print all items in the names list. For name in names, print name. Where is name defined? It's much easier than if you had to write a while loop. A common operation on lists is to do something with each element of the list. Modify the loop to also print out the number of characters in that person's name. Hence, you can use the length property of a string to find the number of characters in that string. Number of characters, name.length. Okay. Oh, I misspelled Alicia. Okay. The code in the loop did not change the original list. It only affected what was printed. It's pretty neat how you can write the instructions for what should happen for one list item and get the code executed for every item. Using a loop can save you from typing a lot of repetitive code. Here are some other variations of what you can do with for loops, including using them with ranges with specific steps instead of incrementing them by one each time. For item in list, print item, iterate over items in a list. For item in B to G, print item, range of characters in an alphabet. For item 1 to 5, print range of numbers. for item 5 down to 1, print item going backwards. For item in 3 through 6, step 2, print item prints 35. A loop is a control flow structure, like if, else, or when expressions you have learned earlier, because it dictates a particular flow for how the code should be executed. Now that you've experimented with creating and using both lists and mutable lists and learned about loops, it's time to apply the knowledge in a sample use case. Put it all together. When it comes to ordering food at a local restaurant, there's usually multiple items with a single order for a customer. Using lists is ideal for storing information about an order. You'll also draw on your knowledge of classes and inheritance to create a more robust and scalable Kotlin program instead of putting all the code within the main function. For the next series of tasks, create Kotlin programs that allows for ordering different combinations of food. First, take a look at this example of output of the final code. Can you brainstorm what kind of classes you'll need to create to help you organize this data? Order, noodles, total. Order 1, order 2, noodles, vegetable, chef's choice, total. From the output, you'll notice that there's a list of orders. Each order has a number. Each order can contain a list of items, such as noodles and vegetables. Each item has a price. Each order has a total price, which is the sum of the price of the individual items. You could create a class or represent an order, and the class to represent each food item like noodles or vegetables. You may further observe that noodles and vegetables has some similarities because they are both food items and each have a price, and you could consider creating an item class with shared properties of both noodle and class vegetable. The class could inherit from, that way you don't have to duplicate logic in both noodle class and vegetable class. You'll be provided with the following starter code. Professional developers often have to read other people's code. For example, if they're joining a new project or adding onto a feature that somebody else created, being able to read and understand code is an important skill. Take some time to look over this code and understand what is happening. Copy and paste the code into the Kotlin playground and run it. Be sure to delete any existing code in the playground before pasting in the new code. Observe the output and see if it helps you understand the code better. Open class item. All right. And we've got a constructor with a val name string, and we've got a val price. So the name of the item, I'm guessing, which is a string, and the price of the item, which is an int. So we've got a class noodles of type item. Okay. Class noodles. Oh, extending type item. Okay. So we're making a noodle class and a vegetable class. And our noodle class, we're passing in noodles and 10, so noodles are $10. In our vegetable class, we're passing in vegetables, and the price is 5. All right. Function main. Okay. Val noodles equals noodles. Val vegetables equal vegetables. So we're creating our objects right here. So we're creating a noodle object and we're creating a vegetable object. All right. And then we're printing out noodles, which is going to print out this. And then we're printing out vegetables, which is going to print out this. You should see output similar to this because we didn't do, what didn't we do? I'll read further. So let's get this started. All right. Just out of curiosity, if I do this, does it fix that problem? Okay. All right. Here's a more detailed explanation of the code. First, there is a class called item, where the constructor takes two parameters, a name for the item as a string and a price as an integer. Both properties do not change after they're passed in. All right. So they are marked as val. Since item is a parent class and subclasses extend from it, the class is marked with the open keyword. Okay. The noodles class constructor takes in no parameters, but extends from item. All right, so noodles class takes in no parameters, but it extends from item, and it calls the superclass constructor by passing in noodles as the name and price of 10. Okay. Say that again? Um, the noodles class constructor takes in no parameters, but extends item and calls the superclass constructor by passing in noodles as the name and price of 10. The vegetable class is similar, but calls the superclass constructor with vegetables and a price of 5. All right. The main function initializes new object instances of noodles and vegetable classes and prints them to the output. Override toString method. When you print an object instance to the output, the object's toString method is called. In Kotlin, every class automatically inherits the toString method. The default implementation of this method just returns object type with a memory address, for instance. You should override toString and return something more meaningful and user-friendly than noodles at whatever the memory address is. Inside the noodle class, override the toString method and have it return the name. Remember that noodles inherits the name property from its parent class item. Override function toString of type string, return name. Repeat the same for vegetable. Override function toString, return name. All right. In the next step, you will change the vegetable class constructor to take in some parameters and update the toString method to reflect the additional information. Customize the vegetables in an order. To make the noodle soups more interesting, you can include different vegetables in your order. In the main function, instead of initializing a vegetable instance with no input arguments, pass in specific types of vegetables that the customer wants. Val vegetables equals vegetables, cabbage, sprouts, onion. Okay. And we're going to put that in the function main. What kind of vegetables did it have? Cabbage, sprouts, onions. Okay. If you try to compile your code now, there will be an error that says too many arguments for a public constructor vegetable defined in vegetables. You are now passing in 3 string arguments into vegetable class constructor, so you will need to modify the vegetable class. Topping 1, topping 2, topping 3. Okay. Okay. All right, no errors. Now your code compiles again. However, the solution only works if your customers want to always order exactly 3 vegetables. If a customer wants to order 1 or 5 vegetables, they are out of luck. Instead of using a property for each vegetable, you can fix this issue by accessing a list of vegetables, which can be any length in the constructor for vegetable class. Okay. The list should contain only strings, hence the type of input parameter list strings. Val toppings list of type list string. Val toppings of type list string. String list val toppings. This is not the most elegant solution in the main. You would need to change your code to create a list of toppings first before passing it into the vegetable constructor. There's an even better way to solve this. In Kotlin, so wait, what was it saying here? It's not the most elegant solution because in the main, you would need to change your code to create a list of the toppings before passing it into the vegetable constructor. Okay, vegetables list of. Okay, now it works. There's an even better way to solve this. In Kotlin, the var arg modifier allows you to pass a variable number of arguments of the same type into a function constructor. In that way, you can supply different vegetables as individual strings instead of a list. Change the class definition of vegetables to take a var arg toppings of type string. Is it val or var? Yeah, var, val. Okay. All right. Only one parameter can be marked as var arg, and it is usually the last parameter. In this case, we only have one parameter in the constructor for class vegetables, so that's the one we mark. This code in the main function will now work. You can create a vegetables instance by passing in any topping and any number of toppings to strings. Okay, so I can take away that other code added to make it work before. I don't need to make it a list of anymore. Okay. Yep. All right. Now modify the toString method of vegetable class so that it returns a string that also mentions the topping in this format. Vegetables, cabbage, sprouts, and onions. Hmm. Name plus space plus toppings joined to string. Okay. Hmm. To specify a different separator other than a comma, pass in the desired separator string as an argument to the join_to_string method. Example, join to string to separate each item with a space. When writing programs, you'll need to consider all possible inputs. When there's no input arguments to the vegetable constructor, handle the toString method in a more user-friendly way. Since the customer does not want vegetables, but didn't say which ones, one solution is to give them a default of the chef's choice, vegetables. Update the toString method to return vegetables, chef's choice, if there are no toppings passed in. Make make use of isEmpty method that you learned earlier. Okay. If toppings is empty, return name chef's choice. Else, okay. Update the main function to test both possibilities for creating a vegetable instance without any constructor arguments and with several. Val vegetables 2. Okay. Okay. Vegetable chef choice. Okay. Verify the output is as expected. Create an order. Now that you have some food items, you can create an order. Encapsulate the logic for an order within an order class in your program. Think about what properties and methods would be reasonable for the order class. If it helps, here are some sample outputs for the final code again. You may have to come up with the following: order class, properties, order number, list of items, methods, add item, add multiple items, print order summary, include price. Focusing on the properties first, what should the data type of each property be? Should they be public or private to the class? Should they be passed in as arguments or defined within the class? There are multiple ways to implement this, but here is one solution. Create a class, order, that has an integer order number, constructor parameter, class order, val, order number of type int. Okay. Does it extend item? I don't think so. What do they have in the order number of type int? Val order number of type int. Okay. Since you may know all the items in the order up front, don't require the list of items to be passed in as an argument. Instead, it can be declared as a top-level variable. Initialize it as an empty mutable list that can hold elements of type item. Okay. Private val item list equals mutable list of item. Private val item list equals mutable list of item. Okay. Go ahead and add the methods to the class definition too. Feel free to pick reasonable names for each method, and you can leave implementation logic within each method blank for now. Also decide on what function arguments and return values should be required. Okay. Function add item, new item, of type item. Function add all, new items, of type list item. Function print. All right. So these are the ones we're going to use. So I'll just copy them, paste them over for now. Over. Wow. Function add item. The add item method seems the most straightforward, so implement that function first. It takes in a new item, and the method should add it to the item list. Item list.add new item. Implement add all method next. It takes in a read-only list of items. Add all of those items to the internal list of items. Okay, item list.add all new items. Okay. Then implement the print method, which prints a summary of all items and their prices to the output as well as the total price of the order. First, print out the order number, then use a loop to iterate through all items in the order list. Print out each item and its respective price. Also keep a total of the price of so far, and keep adding to it as you iterate through the list. Print out the total price at the end. Try to implement this logic yourself. If you need help, check the solution below. You may want to include the currency symbol to make the output easier to read. Here's one way to implement the solution. This code uses the currency symbol, but feel free to modify your local currency symbol. Okay. Print. Okay. Print order number. Okay. Order number. Var total equals 0. For item in item list, print item. All right. Of type. Oh, no, that's just colon. Item, and then whatever it is. Total. Okay. And then it's going to add item to item price and then print everything. I'll go through this and check it out later, see what they did and how they did it. But it'll probably explain it to me right now. So let's just put it in there, see if it works. Yeah. All right, for each item in the item list, print the item which triggers toString to be called on the item, followed by the price of the item. Also, before the loop, initialize the total integer variable to be 0. Then keep adding the total by adding the current item price to the total. Create orders. Test out your code by creating order instances within the main function. Delete what you currently have in the main function first. Okay. Val order 1. Okay. Order 1 dot add item noodles. Order 1 dot print. Okay. Print line. Val order 2. Okay. Print. All right. So update our main that have this stuff in it. Okay. The output for the code above should be the following. Verify that the total price is being added up properly. It is. Great. Looks like food orders now. Okay. Next. Improve your code. Keep a list of orders. If you were building a program that would actually be used in a noodle shop, it would be reasonable to keep track of a list of all customer orders. Create a list to store all the orders. It is a read-only list. Is it a read-only list or a mutable list? Add this code to the main function. Initialize the list to be empty at first, and then as each order gets created, add the order to the list. Val order list of mutable list of type order. Okay. Since the orders get added over time, the list should be a mutable list of type order. Then use the add method on the mutable list to add each order. Once you have a list of orders, you can use a loop to print each one. Print a blank line between the orders so that the output is easier to read. For order in order list dot print. Okay. This removed duplicates in our code and main function to make the code easier to read. The output should be the same as before. Okay. Very cool. And it is. Implement builder pattern for orders. To make your Kotlin code more concise, you can use the builder pattern for creating orders. The builder pattern is a design pattern in programming that allows you to build up a complex object in a step-by-step approach. Instead of returning unit or nothing from the add item and add all methods in order class, return the changed order. Kotlin provides the keyword this to reference the current object instance. Within the add item function and add all methods, you return the current order by returning this. In the main function, you can now chain the calls together as shown in the following code. This code creates a new order and takes advantage of the builder pattern. Val order 4 order 4 dot add item noodles dot add item vegetables cabbage onion order list dot add order 4. Order 4 returns an order instance, which you can then call add item noodles on the add item method returns the same order instance with a new state, and you can call add item again on it with vegetables returned order can be stored in the order 4. The existing code creates order still works, so that it can be left unchanged. While it is not mandatory to change these calls, it is common and recommended practice to take advantage of the function's return value. At this point, you actually don't even need to store the order in a variable. The main function before the final loop to print out the orders to create the order directly and add the order to a list. This code is also known as easy to read if method. This code is also easier to read if each method call gets pulled on its own line. Okay. Hmm. Oh, we didn't make these of type order. Hmm. Okay. And it works. Cool. Congratulations on finishing this code lab. Now you've seen how useful it can be to store data in lists, to mutate lists, and to loop through lists. Use this knowledge in the context of an Android app to display a list of data on the screen in the next code lab. All right. Solution. Here's the solution code for item, noodle, vegetables, and order classes. The main function also shows you how to use those classes. There are multiple approaches to implementing this program, so your code could be slightly different. Summary. Kotlin provides functionality to help you manage and manipulate collections of data more easily through Kotlin's standard library. A collection can be defined as a number of objects of the same data type. There are different basic collection types in Kotlin: lists, sets, and maps. This code lab focuses specifically on lists, and you'll learn more about sets and maps in future code labs. A list is an ordered collection of elements of a specific type, such as a list of strings. The index is the integer position that reflects the position of the element. Example, my list, position 2, which is actually the third element in the list. In a list, the first element is at index 0. Example, my list 0, and the last element is at mylist.size minus 1. So mylist.size minus 1 or mylist.last. There are two types of list, a list and a mutable list. A list is a read-only, and it cannot be modified once it has been initialized. However, you can apply operations such as sort and reverse to the list, which returns a new list without changing the original. A mutable list can be modified after creation, such as adding, removing, or modifying elements. You can add a list of items to the mutable list using add_all. Use a while loop to execute a block of code until the expression evaluates to false, and then you exit the loop. While the expression is true, execute this block of code. Use a for loop to iterate over all the items of the list. For item in my list, execute this code block for each item in the list. The var arg modifier allows you to pass in the variable number of arguments to a function or constructor. Learn more. Okay. Here's more tutorials on these different types of loops and on the lists and on mutable list of everything we just learned and on augmented assignments. All right, so that was part 2 of lists in Kotlin. Um, And I started part 2 at the mutable lists. Part 1, which is just the regular introduction to immutable list or just regular list, is in part 1. All right, guys, so I will see you in the next video.